Hi, welcome to 1.5 Linear Equations in One Variable. First, equivalent equations and the meaning of solutions. An equation is a statement that two expressions are equal. Identity is an equation which is true for any allowable value of the variable. So it's going to always be true. For example, if you end up with like 2x equals 2x or 3x plus 1 equals 3x plus 1. Contradiction is an equation that can never be true. If you end up with something like 1 equals 0, that's never going to be possible. Conditional is an equation that is true for some values of the variables and false for others. We see mostly conditional. For example, if we have 2x plus 1 equals 5, and then x equals 2. There's only one value that works for that, versus all values or no values. Solution is a value that can replace the variable and make the equation a true statement. A solution set is a set of values with which the variables can be replaced to make the equation true. And equivalent equations are two equations that have the same solution set. So far, really this is material that's like Algebra 1 material of this section. So, shouldn't be anything surprising here. An equation that can be a linear equation in one variable is an equation that can be transformed into the form ax plus b equals 0, where x is the variable and a and b are real numbers. These are also called first-degree equations because the power on the variable, the x, is 1. So solving linear equations in one variable. When the equation in the form ax plus b is 0, you would add negative b to both sides. You get ax equals negative b, and then divide by the a. You get x equals negative b over a. So going on to page 2 here, we have a couple of examples to look at. Solve the following linear equations. 5 times the quantity 2x minus 1 equals 3 times the quantity 1 minus x plus 5x. So it's 10x minus 5 equals 3 minus 3x plus 5. I want to get the variables on one side. Oh, that's 5x, by the way. So let me just simplify. 10x minus 5 equals 3 minus 2 or plus 2x. I'll subtract 2x from both sides and I will add 5. That gets the constants on the right side, the variables on the left. 8x equals 8, so x must be 1. Going on to the next one, I'll distribute here the 3. 3x plus 5 equals 3x plus 9 minus 5. So 3x plus 5 equals 3x plus 4. If I subtract 3x from both sides, I have 5 equals 4, and that's not possible. So this is no solution. This is a contradiction. I'm going to go on to the next example here. Solve the following equations. It's singular, there's only one of them. By the way, these examples I use are all from the textbook. You know, I assign every other odd in the textbook. These are the either evens or they're some of the other odds. So 0.08p plus 0.09 equals 0.065. Solve them for p minus 0.09. 0.08p equals 0.56. 0.56 divided by 0.08. P equals 7. So we have 0.08 going into 0.56. 0.56. Move that 2 places, this 2 places. 8 goes into 56 7 times. Okay, solving absolute value equations. Linear absolute value equation, absolute value of ax plus b equals c. To solve this, set ax plus b equal to both positive and negative c. Ax plus b is c, or ax plus b is negative c, and you solve each equation. Warning of extraneous solutions. So I'm going to have to scroll up. You're going to have to pause if you need to write that down. An apparent solution, extraneous solution is an apparent solution that does not solve the original equation. So the above solution for absolute value equations may produce extraneous, not too common for these, but it could. Usually it's more with square roots. May produce extraneous solutions, solutions that do not work for the original absolute value equation. So example 3, we have 3 parts here. Solve the following absolute value equations. So we'll have 3x minus 2 equals 5, or 3x minus 2 equals negative 5. If I add 2 to both sides, 3x equals 7, divided by 3, x equals 7/3. Here if I add 2 to both sides, 3x equals negative 3, and divided by 3, x equals negative 1. So we can check this. X equals 7/3. We have absolute value of 3 times 7/3 minus 2 is at 5. Absolute value of 7 minus 2. Absolute value of 5 is at 5. Yes, it is. And then if for x equals negative 1, we have the absolute value of 3 times negative 1 minus 2. Is that going to be 5? Negative 3 minus 2 is at 5. Negative 5 is at 5. 5 equals 5. Yep, they both work. Now the next one, we need the absolute value by itself. So if we subtract 2 from both sides, the absolute value of 4x plus 3 equals negative 2. Is it possible for an absolute value to be equal to a negative? And the answer is no. This is not possible. So an absolute value must be greater than or equal to 0. So last one here on this part, absolute value of x plus 3 equals absolute value of x minus 7. So we'd solve this by doing x plus 3 equals x minus 7, or x plus 3 equals the opposite of x minus 7. If we subtract x from both sides, 3 equals negative 7. Well, that's not possible. Over here we have x plus 3 equals negative x plus 7. Adding x to both sides and subtracting 3. 2x equals 4. So x equals 2. Let's check that one. Plug it in here, we have 2, absolute value of 2 plus 3. Is that going to be equal to the absolute value of 2 minus 7? So absolute value of 5 equals absolute value of negative 5. 5 equals 5, and it works. Yep. Okay, let's go on down the page a little bit. Solving linear equations for one variable. Solving for a variable, you transform the equation into an equivalent one in which the specified variable is isolated on one side of the equation. For linear equations, we accomplish this by the same method we have used in the above examples. So distance equation, distance equals rate times time, it's an important equation. Interest equations, interest is principal times rate times time, I equals PRT. That's for simple interest, not compound interest. So solve the following equation for the indicated variable. C equals 2 pi r, solve for r. This is the equation for the circumference of a circle. So C equals 2 pi r. If I divide by the 2 pi, r equals C over 2 pi. Next one's a little more work. Solve for h. A equals 2LW plus 2WH plus 2HL. So these two terms have h's in them. I'll subtract the 2LW. So A minus 2LW equals 2WH plus 2HL. So A minus 2LW equals H times 2W plus 2L. I'll divide by the 2W plus 2L, get the H by itself. So H would be A minus 2LW over 2W plus 2L. Okay, we're going to go on to the last page here, so feel free to pause if you need some more time to write that down. Got some word problems to look at. Two trucks leave a warehouse at the same time. One travels due east at an average speed of 45 miles per hour. The other travels due west at an average speed of 55 miles per hour. So here's the warehouse. One truck's going due east. At 45 miles per hour. The other one's going due west at 55 miles per hour. After how many hours will they be 450 miles apart? Well, the question is, how fast are they going away from each other? That's going to be 55 plus 45 is 90 miles per hour. Distance equals rate times time. So 450 would be equal to 90 times t. Divided by 90, t must be 5 hours. So in 5 hours they will be 450 miles apart. Okay, our last problem from this section, again, feel free to pause if you need some more time there. For example 6, find 3 consecutive integers whose sum is 288. Hint, if n represents the smallest of the 3, then n plus 1 and n plus 2 represent the other 2. So n's the first one, plus the next one's n plus 1 plus n plus 2. These are the 3 different numbers, smallest, medium, large. They're consecutive, one after the other, equals 288. So 3n plus 3 equals 288. Subtracting 3, 3n equals 285. And dividing by 3, n would be 95. So that n plus 1 is going to be 96, and n plus 2 will be 97. And that's it. Well, that'll do it for 1.5, linear equations in one variable. Send me your questions. I'll see you guys later. Thanks.